Hello students, I'm Callie Daniels, and in this video we will discuss point-slope form of a linear equation and modeling. Well, the point-slope form of a linear equation is used to write the equation of a line. And to develop this form, we're going to let m represent the slope. So suppose we know the slope of a line, and let x sub 1, y sub 1 represent a given point on the line. So we also know a point. Then we can find any other point xy on the line by doing the following. Okay, so here we've got a picture of our setup. We know the slant or slope of a line, and we're going to call that m. We know a given point x sub 1, y sub 1. And any other point xy will be on this line if it satisfies our slope formula. Remember that the slope is change in y over change in x. So I've written it y minus y sub 1 over x minus x sub 1. So here we've actually got our equation of our line, but we're going to write it in a neater form without a fraction. And so let's multiply each side by our denominator, x minus x sub 1. Okay, that cancels it off the right-hand side and essentially moves it to the left-hand side. And then in our last step, all we've done is just picked up this equation and transposed it. Okay, writing y minus y sub 1 on the left and our slope times the quantity x minus x sub 1 on the right. And this is indeed the point-slope form of our linear equation with slope m passing through x sub 1, y sub 1. Now let's use this equation to write the equation of each line, and we're going to give the final answer in slope-intercept form. So the point that we know, which we'll call x sub 1, y sub 1, is 5, 2. And our given slope is negative 1/3. Go ahead and write your formula. Y minus y sub 1 is slope times x minus x sub 1, and let's substitute values. Y sub 1 is 2, so write y minus 2. That's equal to the slope negative 1/3 times x minus x sub 1, which is 5. So here we've got the equation of our line, but we want to write it in slope-intercept form, and therefore we're going to take this equation and solve for y. Y minus 2 is equal to negative 1/3 x plus 5/3 as we distribute and multiply straight across numerator and denominator. Next, we're going to add 2 to each side. So y is negative 1/3 x plus 5/3 plus 2. And I'm going to write that as 2 over 1. Now to add these fractions, we need a common denominator. Our LCD is 3. So let's multiply 2 over 1 by 3 over 3 by 1. Okay. And let's just kind of step out here to the side. So as we add our fractions, we have 5/3 plus 6/3, and that is equal to 11/3. So our final answer in slope-intercept form, we write y equal negative 1/3 x plus 11/3. Slope-intercept form, you solve for y. Let's take a look at another problem. Here we want to write the equation of the line through 4, negative 2 with slope 8. So we're given our point, x sub 1, y sub 1. We know the slope is 8. Here we go. Write your formula. Y minus y sub 1 is slope times x minus x sub 1. And let's substitute values. Y sub 1 is negative 2, so we've got y minus negative 2. That's equal to the slope, which is 8, times x minus 4. So we've got our equation of our line. Now we simply need to write it in slope-intercept form by solving for y. Y minus negative 2 is y plus 2. Distributing the 8, we have 8x minus 32. Lastly, let's subtract 2 from each side. Y is equal to 8x minus 34, and this is our slope-intercept form. Okay, it's slope-intercept form because we see the slope, it's 8, and we see the y value of the y-intercept, negative 34. Now in example 2, we want to write the equation of the line through the points 4, 1 and 6, negative 2. We're going to give the answer in both slope-intercept form and standard form. All right, so our given information is different this time. We're given 2 points, and 2 points determine a line, okay? But we're going to have to find the slope ourselves. So using our 2 points, slope is change in y over change in x. So let's subtract the y values, choose an order, okay? I'm going to choose the order negative 2 minus 1. Now use the same order with your x's, so 6 minus 4. That gives negative 3 over 2, which is just negative 3 halves. Okay, so our slope is negative 3 halves. Now we're going to use our point slope formula. Okay, we know that the slope is negative 3 halves, and as far as a point, we can choose either of these points to represent our known point. Okay, I'm going to choose 4, 1, simply because it has no negative symbols. I think it's going to be a little easier to work with. All right, so let's substitute. Here we go. Y minus 1 is equal to our slope, negative 3 halves, times x minus 4. And first thing I'm going to do is write this equation in slope-intercept form by solving for y. Y minus 1 is negative 3 halves x plus. Okay, negative 3 halves times negative 4 will give positive. Okay, if we divide 2 into 4 2 times, that gives a product 6 over 1, or 6. So positive 6. Now simply add 1 to each side. Y is equal to negative 3 halves x plus 7. And here we have our slope-intercept form. Now we were asked to write our answer in both forms, so we also want to write this in standard form. So let's just take our previous answer and write it in standard form. Now standard form has your x and y terms on the same side of the equation, so let's add 3 halves x to each side. Almost there, okay? Also, standard form has coefficients that are integers, okay? So integers like 1, 2, 3, 4, 0, negative 1, negative 2, negative 3, and so on. So we're going to rewrite that 3 halves as an integer, okay? And to do that, we need to eliminate the denominator 2. So let's multiply each side of this equation by 2. Okay, multiply the left by 2, and I'm going to write that as 2 over 1. Sorry, kind of got a little merged with my arrow, didn't I? Do the same to the right, multiply it by 2. Now, 2 times 3 halves. Okay, we're multiplying by 2, so we can divide those 2's out. Okay, 2 divides into itself 1 time, and 1 times 3 is 3. So we've got a coefficient 3 for x. Okay, remember to multiply the 2 by y as well. And that's equal to 14. And this is our standard form. X and y on the same side. Okay, no fractions or decimals. And also we want that coefficient of x to be a positive number, which it is. 3x plus 2y is equal to 14. Now in example 3, we're going to just pump up the difficulty level here a bit by writing the equation of each line described, and we'll write our answers in slope-intercept form. Part A, write the equation of the line through the point 4, 2 that is perpendicular to the line x minus 3y equals 7. Well, we've got to remember that perpendicular lines have slopes that are negative reciprocals. That is, their product is -1. So we must determine the slope of our line given. We can do that if we solve for y. So let's subtract x, essentially moving that to the other side. Divide each side by -3. That gives y is equal to, okay, our coefficient of x is -1 over -3, or positive 1/3. 1/3 x minus 7/3. So we can see that the slope of this line is 1/3. And if our line is perpendicular to it, then the slope of our line is -3 over 1. In other words, the slope of that perpendicular line is -3. Okay? So now we're going to write the equation of the line with slope -3 that passes through the point 4, 2. Here we go. Y minus y sub 1 is slope times x minus x sub 1. Substitute values. Y minus 2 is the slope -3 times x minus 4. To write in slope-intercept form, we need only to solve for y. Y minus 2 is -3x plus 12. Add 2. Y is -3x plus 14. Okay, and there is our answer in slope-intercept form. Now in part B, we'll write the equation of the line through 2, 3 that's parallel to 4x minus y equal -2. So similar process here. We're going to solve this equation for y. Okay, I'm going to multiply next each side by -1, which is essentially going to change the sign of each term. Y equal 4x plus 2. So we can see that the slope of this line is 4. We must know that parallel lines have the same slope, and so the slope of the line that we're writing the equation for is also 4. Okay, the slope of the line parallel to this one is also 4. Our line passes through the point 2, 3. Okay, now we're ready to use our point slope formula. Y minus y sub 1 is slope times x minus x sub 1. Substitute values. Y minus 3 is slope 4 times x minus 2. Lastly, just solve for y. Distribute the 4, add 3. Y is 4x minus 5. And there's our answer in slope-intercept form. Woo! All right, if you got through those two problems, way to go. All right, let's look at our last example here, example 4, modeling. This is a really good application of a linear equation. Let's suppose it costs $3,000 to purchase a new copier, and each copy costs 5 cents to make. This sounds about right, okay? As we talk about the fixed cost, okay, that's our purchase cost. We paid $3,000. That is not changing. That was spent. It's done. Okay, but our variable cost is the 5 cents that it costs per copy. Okay, and this is going to change depending on how many copies that we need to make. Next, we'll write our cost equation. I'm just going to step out here to the side. We're going to use the form y equal mx plus b, where y represents our cost and x is the number of copies. And as we think about this equation then, m, the slope, our variable cost is 5 cents per copy, plus our fixed cost, okay, which doesn't vary by producing more or less copies, okay, the 3,000. So our cost equation is cost y is 0.05 times x, the number of copies, plus 3,000. And our fixed cost is always out here by itself, okay? So now our equation, what will be the cost of producing 10,000 copies? Okay, so that's a value for x. We're just going to substitute that for x. Y is 0.05 times 10,000 plus our fixed cost, 3,000. Well, so we multiply 0.05 times 10,000. That's just going to move the decimal point 4 places. 500 plus 3,000, or $3,500. Okay. So if we produce 10,000 copies, that overall cost or total cost will be $3,500. And as our last question, we're going to turn this around, okay? Now we're given a value for y. How many copies are produced if the total cost is $4,000? And you might be able to kind of reason your way through this one. You know, it cost $5,000 for 10,000 copies, okay? And 4,000 is just $500 more, right? So you might guess that, okay, we're dealing with 20,000 copies here. But let's go ahead and walk ourselves through the math. In our equation, y equal 0.05x plus 3,000, okay, this time we're given the y value. So substitute 4,000 for y, and then solve for x. Subtract 3,000. And then divide by 0.05. So you're going to be dividing 1,000 by 0.05, and that's going to give you 20,000. Oop, that's not dollars, that's copies. Okay, if 20,000 copies are produced, made, then that cost is going to be $4,000. So there's our nice application of a linear equation. And our last page is just a summary of what we have with our equations, okay? The form y equal mx plus b is our slope-intercept form. Here we know the slope is m, the y-intercept is 0, b. When might we use this one? The slope and y-intercept can be easily identified and used to quickly graph the equation, okay? If you know the slope and y-intercept, okay, use this form and substitute values, write your equation of your line. Point slope form, the slope is m. We're given a point that it passes through called x sub 1, y sub 1. This form is ideal for finding the equation of a line if the slope and a point on the line, or 2 points on the line, are known. Standard form, ax plus by equals c. Remember that a, b, and c are integers, and our coefficient of x is a positive number, okay, or 0. So no fractions or no decimals will be seen here. In this form, the x and y intercepts can be found quickly by substituting 0 values for y and x, respectively. Our horizontal line takes the form y equals some number, like y equal b. The slope of a horizontal line is 0. The y-intercept is 0b. If the graph intersects only the y-axis, then y is the only variable in the equation. Lastly, our vertical line takes the form x equal a. Slope is undefined for a vertical line. It has an x-intercept called a comma 0. And if the graph intersects only the x-axis, then x is the only variable in the equation. All right, so that wraps up our lecture of discussing lines using our point-slope form. Good luck on these problems. Remember, students, show up, work hard, stay positive. Okay, hang in there.